All right, Module 2. This module, we're talking about inequalities. So in usually means opposite. So in other words, it's not equal. Yeah, that's kind of the idea. Let me show you. Okay, so sometimes you'll see things like a lagoon, like you must be this tall to ride this ride. Okay, how many heights fit that rule? If let's say that was this line right here is 4 feet, then you could be 4 feet a half an inch and it would still work. But you could be 5 feet, 6 feet, 6.5, 5'7", and 5'7 3/4. All of those fit. There's multiple answers and usually an infinite number of answers. Okay, so no drinking under the age of 21. So 21 is your limit, and it's got to be everything above that, right? Okay, so the idea is there's more than one answer. So unequal kind of means not just one, but many. The situation here in the note says a student wants to know what she needs to get on the final to get at least a 90% overall. Should be happy with anything as long as it gives her a 90%, right? So there's more than one answer, most likely. Okay, so we need to go over what these symbols mean, and then we'll go on. Okay, so I'm going to zoom in a little. All right, the difference between these two is that line, and that's it. That is the bottom line of an equal sign. Okay, so if I take this top one and combine it with an equal sign, rather than putting the entire equal sign underneath it, they only take one line. Okay, so a combination of a less than and an equal gives you less than or equal to. And I know I wish there were a shorter way of saying that, but that entire phrase is needed. Okay, on the other side here, greater than and greater than or equal to, same thing. The only difference is that line. Okay, so now how do you tell which one's less than and which one's greater than? Back when we learned these originally, the alligator eats the big number, right? That's true, still does. However, if I said x is less than 3 and I didn't tell you which one was bigger, you would need to know that you use this symbol and you would write x is less than 3. If you get the symbol backwards, it means something completely different. Okay, so like on the lagoon ride, if you got the um, arrow backwards, basically, and you were shorter than that line to ride the ride, you'd be in trouble. So it's completely wrong. It's the exact opposite. So these two are basically opposites of each other, almost. Okay, so how do you tell them apart? Here's a couple ways of thinking about it. Okay, so a less than points to the left, and a greater than points to the right, but I'm going to write it that way so that you have uh, left and right, so greater and less. That's one way. Another way is if you look at this symbol right here, can you see that if I keep turning it, it's going to look like a capital L for left and for less than. Okay, I don't care how you learn how or which symbol is which name, but you need to know it by name, okay? Not just alligator eating the big number, because we don't know what this number is. It's a variable. We don't know is 3 bigger or is x bigger by just looking at the numbers. You know what I mean? Okay, so Another way of trying to figure out which one's which, you read from left to right. You read this way, right? It is greater than or equal to. We're going from left to right. So as I'm going from left to right, I get the x, and then I get the small side and not the big side. Small side is less, okay? If it was this way, and I'm reading sideways, it is sideways, but it's left to right, I get the big side first and little side second. So this is the greater of the two sides. Okay, just a couple ideas. Just keep practicing because you need to know the phrases that match the symbol. Okay, now let's take a look at what they are, what they mean. Okay, in this section, we're going to cover writing them first, but there are multiple ways, in fact, 4 ways of writing the answer. So this is inequality notation. I'm just going to zoom ahead for a second in the notes so you can see what the others are, and then I'll come back and explain. So you have inequality notation right here. You have graphing notation on a number line. You have interval notation, so I'll explain what that means. And you have set builder notation. Okay, so I'll explain what that is. On each different problem, you may be asked to answer differently, so you need to know how to do all 4 of them. Sometimes you'll be asked to do 2 of the 4 or 3 of the 4. So just make certain you know what each one means by name. Okay? All right, let's take a look at inequality notation first. So this is red. X is greater than or equal to 90, just like it says right there. Okay, this one is 90 is less than or equal to X. Okay, if you look at these two things, they mean exactly the same thing. Okay, how do I know this? Let me show you. Okay, on this side, alligator's eating the X, basically, right? It's pointing to the 90. The large side is towards the X. So if I reverse the sides, notice I reverse the symbol to compensate. Large side is opening towards the X. Large side is still opening towards the X. It's pointing basically at the 90. It's pointing basically at the 90. Okay? This is like on an equation. If you said x is equal to 3, you could write it as 3 equals x, and those mean exactly the same thing. We just don't notice a difference when you flip an equation, an equal sign around, because it's the same thing. But when I flip this around, it becomes facing the opposite direction. Okay? Okay, so what does this represent? This says x represents every single number possible as long as it is greater than or equal to 90. Okay? So it could be 90. It could be 91. It could be 92. It could be 93, etc., all the way to infinity. But it could also be 90.1 or 90.01 or any number as long as it's greater than or equal to 90. It could not be 89 because 89 is less than 90, right? It can equal 90 because of that equal to line right there. Okay? This is a way that you can represent more than one answer. This method, you only had one, exactly one answer, and x was 3. That's it. This way represents an infinite number of answers, every single number that is greater than or equal to 90. Okay? All right, let's look at the next type. Okay, this is graph notation. This is the visual way of representing what we did on the other page. Okay, so the other page is x is greater than or equal to 90. All right, so the blue arrow you see is exactly x is greater than or equal to 90. Okay, this red stuff, note that the graph itself is directly on the number 9, not floating over it. It's directly on it. Okay, make certain you're doing that. And I'll show you why when we get to harder problems in this chapter. The top is needed for something else, okay? So make certain it's right on the number line. Okay, let me explain a couple things. Here we go. 90 is where this blue line starts. It's at 90. So this blue line covers every single number on the number line that is greater than or equal to 90 and going forever. That's what the arrow means. If you don't have an arrow, it doesn't mean it goes forever. It means it stops at wherever your line stops, and that would be incorrect. Okay? So right here, I'm going to change. Okay, I wanted to change my color to the same basic color that they have. Okay? So this dot right here on the 90, it is a closed dot because of that equal to line. If I were to graph x equals 90, it would be that dot right there. Now, if I were going to graph x is greater than 90, that represents this whole part moving to the right, everything larger than that dot. Put them both together and you get that arrow with the dot at the end, which is, whoops, that blue line, right? Okay. The end point, the solid dot here, matches the symbol. Okay. So right over here, summary, if we use an open circle, if the inequality is one of these two, and we use a closed circle, which is what we just did, a filled in circle, if it's one of these two. Okay. So let me draw another one. If, let's say this is 10, 11, 12, and I was graphing x is greater than 11, I would have an open circle at 11 because it cannot equal 11. It's greater than 11, but not equal to it. And now everything over here. Okay? Now make your number lines lines, please. Don't do like an open circle and then squiggle. Okay? It's got to be nice, neat lines. That's what it's supposed to be. It represents direction. It has to be two-dimensional. Okay? Or one-dimensional, excuse me. Side to side, and that's all you get. Two-dimensional is this one because it's going up and down and side to side. Okay, reiterating. Here we go. Number line has to have arrows on both sides. These tick marks should be as equally spaced as you can get them without getting a ruler out. You can start anywhere. You don't have to have a 0 on the number line. You can start anywhere you want. Okay, so let's say I started at negative 20. The next one to the right, you would add 1 to it, or negative 19. Do you have to label every single tick mark? Absolutely not. Okay, look what they did up here at the top. They labeled 3 out of all of them. And I will show you as we get to some problems exactly which ones you have to write. But I'm going to put another equation, or inequality rather, on this new number 9, and I'm going to say x is less than or equal to negative 18. Okay, less than or equal to, so this symbol, because it has an equal to sign, is going to be a filled in dot. And less than means to the left, so I'm going to fill in over here. Okay, another way you can look at that is, like I said at the beginning, this symbol looks like an arrow pointing to the left. So this points to the left. Another way, all these kind of things. See this little purple arrow that less than symbol is? It's exactly the same shape as this end of the arrow over here on the left. Okay, let's look at the next type. Okay, this is called interval notation. And this is a way of typing what that graph on the last page said. This is what computer code likes because this is the beginning, the end, this is what the mark looks like, this is what the mark looks like. It's very cut and dried and easy to type, and it's easy for a computer to understand. Okay, so it's the interval that represents your answer, the interval of all numbers that need to be included in your answer. Okay, so here's 90, and it was a closed circle at 90, and then I'm going to change my thickness just a little bit. There we go, to the right. Okay, so how does that bracket 90 comma infinity parenthesis fit the blue line? In exactly the same order that you see it. Okay, so the bracket means it's closed circle, and the 90 is where the circle is. The infinity represents the arrow over here. It points to infinity, forever. Okay, and the parenthesis is because it won't ever get to infinity. It's going to continue forever. If it stopped at a certain number, then that would be a bracket over here. It stopped at 90, didn't go any further down, so it's a bracket. Okay? When we get to solving problems, it will make more sense. So this is kind of just throw everything at you at once. Okay, so negative infinity is written like this. So on the right side of the number line is positive infinity, and on the left side of the number line is negative infinity. Okay, when you're typing this in Canvas for your answer, you type, I think it's little lowercase o, right next to each other. It's not the zeros, it's O. Okay, and you would have to put a negative in front of it for that side, or, whoops, sorry, positive OO over on this side. And everything I just explained up here about the bracket and the parenthesis and the closed circle and all that, I will explain again when we get to a problem. Okay, the third way, whoops, try it again, fourth way. Let me write the number line again. Okay, so there's the number line that we have, and it represents x is greater than or equal to 90. That was from the very original. Okay, if you remember, the equal sign makes it a closed circle at 90, and it's pointing to the right, so the arrow goes to the right. Okay, interval notation on this from the other page just before this would be 90, and it continues through. So this is one endpoint, and the other endpoint of that blue line, so one endpoint, another endpoint is positive infinity. And because it can never get to infinity, you have to put a parenthesis rather than a bracket. Okay, all of that, and then you have this one. This one is actually the easiest, even though it looks complicated. Okay, so this means these little squiggly brackets mean it's a set, more than one answer. Okay, it means the set of all values. So if you were to have a set of numbers that represented 0, 1, 2, 3, dot, 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 that would represent all of the whole numbers that we have, starting at 0, ending at infinity. Well, it can't end, right? It's a dot, 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 goes forever. So the set notation means more than one answer. Inequalities have more than one answer, right? So it makes sense to use them. Now what this means is the set of all x's such that x is greater than or equal to 90. Okay, x is greater than or equal to 90. This part just goes right in there. Okay, so let me rewrite this bottom part. And we have the set of all numbers, and the form of that number is going to be x, because that's the variable we used right here, such that, and then you write the inequality answer right there. And then end of the squiggle brackets. Okay, these are technically called braces. Okay, but set notation is fine. Okay, let's take a look at some problems. All right, your notes say practice. It doesn't say your turn, it says practice. So I'm going to do them with you. If you want to try them on your own first, you're more than welcome to, but I'm just going to dive right in. Okay, you're going to graph this inequality, and you're going to write an interval notation and set builder notation. So basically, the problem's already been solved. This is the answer. Okay, so here we go. You have a number line already drawn. You do not have to have a zero. You can if you want. If you want to put a zero here, for example, you want to count by fives, that would put 9 right here, right? That just makes life a little bit more complicated than you need to be right now. So all I would do is call one of the lines 9. That's all you need to worry about. Okay, this does not have an equal to line in it, right? There's no solid line below it, an underline, if you will. So this is going to be an open circle. Means it's starting at 9, but it can't equal 9. So even though this circle is kind of big, it still represents everything. It will represent, everything past 9, but not 9. So technically we can see some numbers in that little gap there, but they don't exist. Okay, it's that circle means this 9 is not included, but everything exactly to the left of it is, or to the right of it, left of it, whichever we need. Okay, so which one do we need? This symbol is pointing to the right, so we're going to make our arrow go to the right. Okay, so start at that open circle and continue over. Okay, I'm using a thicker line, and you saw when I did it before that you just make it thicker, just don't squiggle it, please, 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 please. All right, so that's what graph notation looks like. We're done. We have the anchor spot, which is 9, and open or close circle, and going one direction. Okay, how do I represent that blue part as an interval? All right, what you do is you look at both endpoints, so the left and the right. At the left, we have an open circle at 9. Open circles mean parentheses because it doesn't equal 9. So an open parenthesis at 9. And on the other side, over here is an arrow going to infinity. So the other side is going to be infinity, and it's also going to be a parenthesis. And then you put a comma in between. Okay? That's interval notation. This means all of the numbers between 9 and infinity, not including 9, not including infinity. Okay, set builder notation. Like I said, this is the easy one. I know it looks weird, but it's easy. Okay, what variable am I looking at it over here? It's not an x this time, it's a y. So you're going to write the set of all y values such that, and then you write your answer. Y is greater than -9. Finish the bracket, or the braces. Okay? All right, let's try the next one. So we've changed variables. If I were to do set builder notation right now, that would look like the set of all x's such that x is less than or equal to -7. This thing goes right there. So it's the easiest one. You don't even have to do anything, right? Okay, graph notation. Interval notation is easier to get from your graph notation until you can hold all that information in your head because it makes sense. I wouldn't even try to do that. Okay? Do the graph first and then do interval notation from the graph. Okay, this one starts at -7. So I'm going to make one of my lines equal -7. Doesn't matter which one because the graph goes infinitely far in both directions. So sure, we're going to look at the section that has -7 right in the middle. So put it in the middle. Put it wherever you want. Okay, now this one does have an equal to line there, right? This is a less than or equal to symbol. So that means the circle at 7 is filled in because it can equal -7. Okay, and now this symbol points to the left, so our blue line goes to the left. Graph notation is done. Okay, now how do I write it in interval notation? You look at, again, we read from left to right. So the first endpoint we get to is this arrow, right? Arrow means infinity, so infinity has to be a parenthesis. You'll never get to infinity. It's the left side, so it's negative, comma. What does the right endpoint of that blue line look like? It's a solid dot at -7. So -7 is where it ends, and it's a dot, so it uses a bracket instead of parenthesis. Okay, not too bad, I hope. I actually really think these are fun, but I know I'm weird. Okay, next one. This one is called a tripartite. How's that for a weird word? Tripartite. Okay, 3 parts, basically. Okay, it has a left, a middle, and a right. And in between each of those parts, it needs a symbol. Those symbols have to point in the same direction. Okay? They have to both go this way or they have to both go this way. It will not make sense if you do them one this way and one that way. Okay? The reason is every part of that tripartite has to make sense, or the other two have to make sense if you take one part out. What? Okay? So, for example, not using algebra for a second, if I said 1 is less than 2, which is less than 3, if I were to take the 3 off, that makes sense, right? I'm actually going to scribble it out. Here we go. 1 is less than 2. That makes sense. If I were to take the 1 off, 2 is less than 3. That has to make sense. Notice I've been scratching out the inequality that went with it, because if I just took the 1, nothing is less than 2, which is less than 3. You can't have that. Doesn't make sense. I mean, not a number. Okay? So I need to scratch out the symbol with it so that what I have left makes sense. Okay, so now when I'm scratching out the 2, I have to be able to take either symbol out. I can take this one, which now it means 1 is less than 3, which is true. Or I can take this one and it means 1 is less than 3, which is true. If I did it backwards, it wouldn't work. In fact, I don't even know how to write it to make it make sense for you. So if I were to put the 3 in the middle and the 2 out here, okay, so less than, greater than. Okay, so if I scratch out the 1 and take its symbol, 3 is greater than 2. Yep. If I take the 2 out and leave the 3 and the 1, 1 is less than 3. Yep. But if I take the 3 out, which symbol do I take? I have to be able to take either one. If I take that symbol out, 1 is not greater than 2. If I take this symbol out, 1 is less than 2, so that works. But they all have to work all the time. Okay? One last thing in this regard, and then we'll go back to the problem. If I were to write it this way, that makes perfect sense. 1 is less than 2, which is less than 3. If I wrote it completely backwards, remember at the beginning how I explained here it's pointing to the 1. So when you reverse it, it has to point to the 1. Okay, so we would write it this way. The open big side goes to the 3. So the big open side has to go to the 3. Okay, so are those two things the same thing? Yes, they are. But your mind, your mathematical mind, if you will, likes to have things in the order that we're used to seeing them. We count 1, 2, 3. We don't count 3, 2, 1. Okay, so you want to use the one that has smaller numbers on the left, larger numbers on the right, which means these two should be less thans in some format. Less thans or less thans or equal tos. This is correct, yes, but Canvas will not accept it. Computer programs generally don't accept them. Okay? A lot of explanation on a tripartite. Okay, so how do I write this one as graph notation? First of all, I look at this part. -1 is less than x. There is no equal to there, so it's going to be an open circle at -1. Then I look at this part. X is less than or equal to 3. So it does have an equal sign. That's going to be a solid dot. This one will be an open one. Okay? The pink dot's going to be at -1. That's where it goes. Okay? So I'm going to put a -1 down here and open circle. And counting, this would be 0, 1, 2, 3. You don't need to put those numbers. All you need, is 0, 1, 2, 3 is going to go right here. So we're going to put a 3 right there. And we're going to have the closed circle that we talked about up top. Okay, so far so good. Makes sense. Now, because x is in between these two, your graph is going to go in between those two. Okay, that works really easily. So the left part is your left dot, the right part is the right dot, your variable is in the middle, which represents all of that in the middle. Okay, so there's your graph notation. Interval notation. We're going to read it from left to right, and the first thing we get to is -1 with an open circle. So it's going to be parentheses, -1. The other endpoint, the one we get to second, is a 3, but it's a closed circle. Okay, so this represents open at -1, closed at 3, and everything in between. Set builder notation. We could have done this one first. Okay, it's using the variable x, and you just write the entire tripartite because that's your answer. And you're done. Okay, so far, the answers have been already given to you. This is the answer. This is the answer. This is the answer. How do you get the answers? Okay, you're going to be solving inequalities basically like solving equations. There are a couple things that are different, but in general, it's exactly the same. Okay, and I'll get to this. The inequality sign could be reversed. We'll talk about that when we get to one. Okay, but for now, let's take a look at this one. It says solve graph and right interval notation. Those are the three you're going to see together most often. Okay, so here we go. All right, from what we did before, we drew the line at the equal sign, right? There is no equal sign. This time it's the inequality sign. That's still the center of the equation. or in this case, center of the inequality. So I still want to get x by itself, so I still want to get rid of the add 4 first. So I'm going to subtract 4, so these cancel. I get x all by itself on this side. 5 minus 4 is 1. And you leave the inequality sign as is unless one of these three things happens that didn't happen here. So we're not going to really worry about it yet. I will let you know when it does happen. Okay, so for right now, just leave the inequality sign until I tell you otherwise. So that is now our answer. This is solving it. We did it. Okay, now we need to graph it. So number line. And I'm going to put a 1 someplace. I usually center them unless it's a tripartite and I have to put them on the ends, at least for now. Okay, is it going to be open or a closed circle? Because it does not, sorry about that, does not have an equal sign, it's going to be an open circle, right? Because this points to the left, I'm going to draw my graph to the left. Okay, there's my graph. Graph is done. Now I need to write it in interval notation. So we're looking to see what the first endpoint is, open at negative infinity. Okay, open. Parentheses mean open. It can never get to infinity. Okay, then what does the other endpoint look like? So comma, other endpoint is an open circle at 1. So 1 and an open parenthesis, if you will. And that is interval notation. You're done. That's all you need to do. Wasn't too bad. Okay, go ahead and try yours. It shouldn't be too hard either, but pause the video, go try it, and then come back. Okay, normally I wouldn't draw the number line first. I would do the solving part first and draw the number line when I'm done, but I know this is a short one like the last one. Okay, here's the center of my equation, or inequality. I want to get y by itself, so I'm going to add 10. And I get y is greater than or equal to 12. So put 12, and it's going to be a closed circle this time because of that equal to line. And this points to the right, so my number line is going to be filled in to the right. And the graph is done. Okay, so the first endpoint is closed circle at 12. So closed at 12. Then the other endpoint is infinity. Arrows always represent infinity, and infinity always has parentheses because you can never get there. And we're done. Okay, number 2. You can see that the problem got quite a bit harder, but if that were to have been an equal instead of a greater than or equal to, you could solve this. This was chapter 1. We want to get the variable on one side. So we get 1x minus 14 equals negative 16. Get rid of your extras. So x is equal to negative 2. We did plenty of those. We're going to follow that same process using greater than or equal to as the center instead of an equal. That's it. Same exact steps. Get the variable on one side. Okay, on inequalities, always move the variable to the left. Okay, if you have the variable on the left, and this is not the same problem, okay, I'll even change the variable. Here we go. If I had n is less than 2, then when I graph that, I can do that shortcut, meaning it points to the left. And I'd have it open circle at 2, right? Okay. If it's backwards and your variable is on the other side, if you had it this way, you can't use that. It would be exactly backwards. Okay, so just get used to moving the variable to the left with inequalities and you will be better off, so you don't have to remember that. Okay, back to the problem. Here we go. So we have 1x left minus 14 is now greater than or equal to negative 16. Add 14 to both sides to isolate the variable completely. And we get x is greater than or equal to negative 2. Okay, so we've solved it. Now let's graph it. Do you have to write those tick marks? Not really. If you want to do it without and you just want to put a negative 2 on there, that's absolutely fine. Okay, open or close circle. It's going to be closed because it has an equal to line. And there's the shortcut that I'm going to use to figure out which direction to shade. I'm going to shade to the right. So it goes this way. Okay, so there's interval notation done. And final step, what is this endpoint? It's negative 2, and it's a closed dot. And it goes to positive infinity, and it can't equal positive infinity, so it's a parenthesis. And you're done. Okay, just because I can, I'm going to show you that set builder notation looks like this. The set of all x's such that, and then you write your answer. X greater than or equal to negative 2. And you're done. Okay, next problem. Okay, multiply and divide is where you end up with some issues. Okay, this explains how to do it with variables and that you have to switch the inequality symbol around. Let me explain it with numbers. Okay, when you see variables, sometimes it doesn't make sense to your mind, but this should. Okay, let's say I have, totally make up a new problem. 4 is less than 10, right? Not even a variable, right? Okay, according to what we learned in chapter 1, whatever you do to one side, you have to do to the other side. So I can add 1 to both sides, and I will get 5, and I would get 11. 5 is still less than 11. That's not a problem. I could subtract something from both sides. Minus 5 minus 5. I would get negative 1, and I would get 5. Negative 1 is still less than 5. That's not a problem either. Okay, I could times both sides by something. So let's times by 3. I would get 12 and I would get 30. Still less than, not a problem. Okay, let's divide both sides by something. 2. 4 divided by 2 is 2. 10 divided by 2 is 5. It's still less than. The problem comes when you have a multiply or a divide by a negative number. Okay, so let's make this 2 right here a negative instead. So on the left-hand side, 4 divided by negative 2 is negative 2. On the right-hand side, we have 10 divided by negative 2, which is negative 5. Having negative $2, basically, is better or bigger than having negative $5. The inequality switched around. Okay, so when this number on both sides is negative, when you're dividing, you flip the inequality around. And that's the symbol I use so you can tell that it flips around. Okay, I'm going to go back to the same problem. And this time we're going to times it on both sides by a negative 3 instead of a positive 3 that we did the first time. Okay, so on the left we get negative 12, and on the right we get negative 30. Negative 12 is bigger than negative 30. Temperatures are warmer at negative 12 degrees than at negative 30 degrees. Not by much, but it's still truth, right? Okay, so switches again because this number, when we're multiplying, is negative. It has nothing to do with the original black numbers, the 4 and the 10. Okay, they can be anything. It's the number you times both sides by. Okay, all right, let's look at some problems. It says your turn. So you can try it if you want, but I'm going to explain. Okay, so here we go. Let's zoom in on this first one. And here we go. So solve, graph, write an interval notation. I'm going to solve it first. Here is your center, right where the inequality sign is. Here's my variable. There's my coefficient. I want to get rid of the negative 3. Okay, so I'm going to divide both sides by a negative 3. And that should be a flag for you right there. It's like, oh, wait a minute, I need to do something. Okay, 3's cancel, negatives cancel, we get x. 21 divided by negative 3 is negative 7. But we have to flip it around because that green 3 was negative. Okay, so this is now going to be a less than. Okay, let's do a number 9. And negative 7 is going to be an open circle and going to the left. Interval notation, what we get to first is negative infinity, which means it's going to be a parenthesis, and it goes to negative 7 with an open circle. Okay, so there we go. All right, now let me explain one thing that I didn't hit really hard. Everything in this blue arrow is an answer to this inequality, right? So I could choose any one of those infinite number of dots that make up that line, plug it in here for x, and this will be true. Okay? Say, for example, I chose negative 10 right there. So I'm going to do negative 3 times whatever x is greater than 21. That's this original equation. Inequality, I keep saying the wrong thing. Put a negative 10 in there. That's a 1, I promise. Let me fix it. There we go. Okay, so on the left we get positive 30 is greater than 21, which is true. If I were to try something on the other side, let's go over here and try 0, for example. And I'm going to put that in for x. Okay, 3 times 0, anything times 0 is 0. 0 is not greater than 21. That's false, which means the number that I chose over here cannot be in the solution because it made it false. So that's why it's not shaded over here. The negative 10 made it true, so that's why it is shaded where the negative 10 is. And I erased part of my graph over here, or my interval notation, sorry. Okay, let's do number 4. So here we go. All right, we're solving the equation first. So there's the center. The left-hand side looks a little crazy, but I'm going to times both sides by negative 5 to get rid of the fractions. Okay, so the negative 5 cancels, and I get x add 4. On the left, or sorry, on the right, I get negative 5. But because this green 5 was negative and I'm timesing, I have to switch the sign around. Okay, so it is now a less than. Keep solving by subtracting 4, and we get x is less than negative 9. Whoops, let's make that in black. X is less than negative 9. Okay, right here, I times both sides by a negative and I flipped it. Right here, this 4 is also negative and I didn't flip it because this is subtract. You only flip when it's multiply or divide. Okay, so you flip the inequality sign when you multiply or divide both sides by a negative. Doesn't matter that you started with a negative or not, it's that you multiplied by a negative, the green number. Okay, this 4 was negative, but it was subtracting to cancel the add, so I didn't. Okay, all right, number 9. So at negative 9, it's going to be an open circle going to the left because that's the way the arrow points with the variable on the left. Starts at negative infinity, which means parenthesis, goes to negative 9. It's an open circle, so it's also a parenthesis. Okay, last one here. So I'll graph and right interval notation. There's one thing different here. The variable's on the other side. Let's just keep going and I'll show you. There's the center. We're going to divide by a positive 4. So nothing changes, right? A and negative 4. So you would read that negative 4 is less than or equal to A. You always read from left to right. Okay, I told you earlier that you should always have your variable on the left so that you can use the shortcuts I taught you, or the tricks rather, they're not shortcuts. So what I'm going to do is switch the sides. If I switch the side, switch the sides, you get the variable first. It's pointing at the 4 and the big side's at the A. So it has to point at the 4 and the big side has to be at the A. Okay, so it switched the inequality when we changed sides. Okay, so A was on the left, needed to be on the left, it was on the right. Negative 4 was on the left, now it's on the right. So when you switch sides, you have to flip the inequality as well. Okay, so negative 4, and it's going to be a closed circle because of the equal to, and points to the right. That's what I wanted to use. Okay, so it points to the right, and make certain you're using the final symbol, this one, in your answer, not the original, because you've changed it in the meantime. And we start with a negative 4, and it goes to positive infinity with a parenthesis, because parentheses always go with infinity. Okay, there we go on those 3. If you did them yourself, hopefully you did well. And this is a little bit longer section for explanations, and I apologize. Okay, so now let's get a little bit harder. Here's your center. We're going to subtract 11, right? So we end up with negative 3x. Do I switch the sign here? No, because that green 11 was a subtract. So negative 24, right? Okay, divide both sides by negative 3. So I get x and positive 8. Do I switch the sign here? Yes, because I divided by a negative 3. Okay, so switch that one around. And that's my first answer, my solved part. Okay, graph it. There's 8, and it's going to be a closed circle, and it's going to point to the right. So here we go, to the right. There's your graph. Interval notation is closed circle at 8, and it goes to infinity with the parenthesis. Okay, these really aren't that hard, are they? I certainly hope you don't think so either. Okay, over here, your turn. So go ahead and pause, work it out, and come back. All right, there's your center. I have variables on both sides. Because it's an inequality, I'm going to move my variable to the left. I don't even have an option. I'm just moving it to the left. Okay, so now I have 2x, add 3. Don't change that because it was a subtract. Okay, then we're going to subtract 3 from both sides. And I can feel some of you panicking already. Zeros are perfectly fine answers, so don't panic if you get a 0. And again, I didn't flip it because that 3 was subtract. It wasn't multiply or divide. Okay, now I'm going to divide by 2. And 0 on the top is okay. So the answer is 0. All right, there's first part. Second part, here's 0. Open circle at 0, and it goes to the right. Open circle because there is no equal sign, and the to the right because that's the way the inequality symbol points. Okay, open circle at 0, so parenthesis 0, comma, infinity with a parenthesis. How'd you do? Hopefully you got it. Okay, I'll do mine. You can do yours. You can pause it right here and see if you can do both of them. Totally up to you. Here we go. Okay, here's the center. I cannot do anything on this side, but I can distribute on this side. So I'm going to leave the left exactly how it is and distribute on the right. So I get negative 4x minus 4. I have a variable on both sides, so I want to get it to the left. So add 4x. I end up with negative 2x minus 3 is greater than negative 4. Let's get rid of the extras, which is the 3. So add 3 to both sides. And we get negative 2x, still greater than negative 1. Now on this line, let me continue this down a little bit more. On this line, I'm dividing by negative 2. Okay, so that is going to flip the inequality, right? So we flip it around. A negative divided by a negative is a positive. Okay, so flip it here. Fractions are fine. So at 1/2, it's going to be an open circle, and it's going to be shaded to the left. So this way, whoa, got a little carried away there. And interval notation starts at negative infinity, so parentheses, and then it goes to positive 1/2 with an open circle. Okay, yours, here we go. If you haven't tried it already, pause it, try it, and come back. So we're going to distribute the 3. We get 3x add 15 minus 1 is greater than or equal to, distribute the 5, so we get 5x minus 5 add 7. Now we have like terms on both sides. So these two and these two, right? Remember, you never do like terms across that green line. So 3x add 14. Nothing that we need to flip the inequality for, so it stays greater than or equal to. And then we have 5x add 2. Get the variable over on the left. So minus 5x. Those cancel. And I do not flip because I was just subtracting. So we get negative 2x add 14 is greater than or equal to 2. Let's get rid of the extras. So minus 14. And we get negative 2x. Don't switch it because all we're doing is subtracting. So it's greater than or equal to negative 12. Now we're going to divide by the coefficient. So divide by negative 2, divide by negative 2. And here you're going to flip it because you divided and it was negative. So x is less than or equal to 6. Okay, graph it. You're going to have a closed circle at 6, and it points to the left once we flipped it, right? So we're going to shade to the left. So you can see then if we didn't flip the inequality sign, I'd be shading the opposite direction, which means my interval notation would also be off. Okay, so that's not a good mistake to make. All right, so starts at negative infinity. So it's a parenthesis, and it goes to 6, and it's a closed circle, so we need brackets. Okay, hopefully you're getting this. Okay, now on my number 7 here, I moved the 4 over to the left because that's what I told you to do. But if you, for some reason, wanted to bring the 6 to the right to make the coefficient of x positive, you can do that. Let me show you on the next page because that's what they did. Okay, so that's what they're saying. Let's take a look at it right here. Okay, so we're adding 6x to both sides instead, and this is what we end up with. Just keep going. I'm going to get rid of the extras, so we're going to add 4 to both sides. This gives you 1 is greater than 2x. Divide both sides by 2, so here they go. These cancel, and we get x. Did not flip the inequality because that was a positive 2. So is that my answer? Not yet. You have to flip it around so that your x is on the left, which means the inequality points to the left, or points to the x. So when you flip it, it has to continue pointing to the x. This is a valid answer, but this is the one you want because that's how computers read things. That's how programming works. That's how algebra works. That's how graphing works. So keep your variable on the left when you have inequalities. Okay? Now, last thing before this video is over. Okay? Read your directions so you know what they're asking for. If you answer it in set builder notation, but they wanted interval notation, you'll miss it, even if the set builder notation is written correctly, because that's not what they want. It's not programmed into the answer. Okay? Same thing on your exam. You don't want to miss it because you didn't read. Okay, now also you're going to have sometimes 2 or 3 different boxes. So for example, I just looked through your Canvas assignment, and question number 8 asks for the solution on a number line and set builder notation. Okay, so you've got to make certain you understand which ones they're asking for. But if one of them is, yeah, let me do one like that. Here we go. So I'm just going to write the answer that we would have had. Let's say the answer is x is less than or equal to 2. There's your number line, and you have to graph it. Okay. Speaking of which, on your Canvas assignment, it has this. This has this, a solid dot, and an open dot. Okay, and then it has all of these marks already made, already labeled. Okay, so if this was 0, they would go, seriously, all of them are labeled, so you can't possibly mix up your numbers. Okay, so what you would want to do, this is a filled in circle, right, because of the equal sign. So you're going to click on the filled dot, and then click right here. And it will fill in or put your dot right there on the 2. If you choose the wrong dot, right over in front of this is a clear all button. Just clear it and use the other dot. Okay? And then once you get that done, you're going to click on this button to draw the line. It has both types of lines. This is the one that is on the tripartite, so it's in between the 2 dots. This one is towards infinity. But if it's less than, like this one, you would still hit this. You'd start your cursor right here, and then you would drag it this way and let go right here, and the arrow is going to show up. Just like that. The computer does everything for you. You don't even have to worry about it. It's pretty awesome. Okay? Let's say, though, that you didn't get the graph right. You made a mistake. Let's say maybe you got an open circle instead of a closed circle. Okay, so you chose this one and clicked on the 2, so it went open circle. And then you dragged it to the left, just like I showed you. So you click, drag, let go, and that shows up. Okay, so you missed part of that one, and the computer will mark part of that wrong. Let's say that you want to fix it because you recognize that there was a mistake. Over here, there's a button that says clear all. So just clear it, start over again, hit the right button, and go from there. Okay, I'm going to continue this way to show you what the computer does. Okay, because you're doing set builder notation, you have a box here that you have to fill in your answer for. Okay, so if you're telling the computer what this blue line looks like, let's say you wrote x is less than 2 because it's an open circle, right? This matches your graph, so it may not be marked wrong, even though it is wrong because it should be less than or equal to. So sometimes one of these two will be right and the other will be wrong when neither one of them match your answer. Okay, so if you get either part wrong, just start over. Okay, I'm going to no, I'm not. I'm just going to fix this so that it matches what we have, so that if you pause right here, you won't think that I blew it. Okay, I totally apologize for such a long video, but this is the section that most people mess up on in this chapter. If you don't get this part right, then the rest of it's going to be a little bit rough. So I apologize again for making it so long, but you really needed the information. Okay? Alrighty, we'll see you in class.